I'm going to tell you a bit about the story of Port of Rotterdam because it's like Bart said from Antwerp, it's a broad subject. And but I'm going to shortly introduce you to Port of Rotterdam itself. Like you saw in the picture before, it's a very long port, 42k long, almost outside of the city, so that's kind of helping us in our NOx emissions. But as you can see, 100,000 inland vessels arriving in our port yearly, and 30,000 seagoing vessels also arriving in our port each year. So a lot of emissions related to that, but the positive side, the largest port in Europe, so doing the most of the business, and having as a second best the Antwerp port. So I think that a lot of the challenges that we see is also the challenges that you've heard before, and I hope I'm going to provide you with some new information. As the Port of Rotterdam, we are landowner of the full port. What our customers do, they rent out land from us. It's about 50 years long lease periods, so we have a long-term contracts with our customers. The port is not only surrounded by the city of Rotterdam, but we are surrounded by several other villages or small towns. So it's not only the NOx emission of the Port of Rotterdam, which is challenging for us, but also the emissions of the other residential areas that we see. You can see them by the grayish areas, but you probably can see that I'm not able to point on the map because it's digital this time. But we also have as challenges is nature areas. We have a lot of nature areas quite near the port. You see them all in the green positions. And that's also something that we really need to take into account with all the activities that we have as a port and the things that we do as a port authority. So it's not an easy job managing this port, but we manage quite good. But what we focus on is, and I think I saw it in previous presentations, we're not only looking at air quality, we also look at challenges with climate, noise, and smell. So often you provide dilemmas, sometimes a solution which needs some NOx emissions. I heard the example with Ineos. We've seen that with our CCS pipeline, Porthos, in which we went to court because there was a small amount of air quality NOx emissions needed to build this pipeline in order to extract a lot of CO2 emissions from our industry in the port. So yes, we do see some challenges, but we try to focus at all challenges at the same time and find the best solutions. I have to admit that the dominant part of our work as a Port Authority focus on climate emissions and air quality emissions, so I'm going to dive a bit more into that one. Like you probably know, and what you saw in all the studies that we've done, the main emitters for those two are our industry in the port and the marine shipping. But it's also kind of a positive side. NOx reduction has been there. I heard in a previous presentation somebody said clean air policy works. It does. It shows you in the graph, it shows you in previous graphs. We have to work hard, but you see reduction, but we're still not there yet. It's still a challenge, and especially with the new standards, it provides us even more challenges. But what we have done in the last couple of years is mostly focus on shore power for inland shipping. We are also electrified already our new terminals, and we're electrifying the new expansion of the terminals. And what we also see is reduction of sailing by inland ships really helps. And of course, the NECA area really provided some help in reducing these NOx emissions. So you see that a lot of work has already been done, but now we still need to do a lot. And I think that the challenges that we see, I think that a lot of presentations also focused on the new directives of European standards, but we also saw that in the national government there's quite stringent requirements, and that also provides us with some extra challenges if there's a huge nitrogen discussion in the Netherlands going on. So that kind of doesn't always help us with some activities in the energy transition, because sometimes a nitrogen emission is needed to, for example, build something which helps us in the climate discussions. So some reduction of CO2, for example, electrolyzers or other solutions. So that's also there's always like a fine balance that as a port authority and our customers needs to work on that. But that leaves this interesting jobs. But But what we have is also a large CO2 emissions. And I'm focusing on that because what we also see, and we saw it in the previous presentations, that a lot of these emissions are linked with each other. So our dominant focus is on the CO2 emissions, and by that we also reduce a lot of NOx and other emissions in our port. We have a huge challenge for that. Like you see, if you look at our CO2 emissions in the port, the base year is 1990 for the reduction that we need for to comply with the Fit for 55. And you see that actually we have a higher emission than we had in 1990, so still a long way to go to get to the 2030 target, but working really hard on that. And fortunately, our portfolio pipeline of opportunities is quite good, but still everything needs to happen, and it needs to happen in Rotterdam. So in order to get to this target. So therefore, within the Port of Rotterdam, already in 2016, we've built up this energy transition program, which is based on 4 pillars. You can see them on your slide. So pillar 1, efficiency and infrastructure, and that's where we really look at what kind of infrastructure is needed. For example, the example of shore power. Shore power asks a huge amount of electricity. If you have a container vessel arriving at your port, it could already kind of extract all the electricity that you need, for example, for a large village. So you need to comply with that. You need to ensure that everything is future-proof. Then pillar 2, a new energy system. It's mostly focused at hydrogen. So creating either hydrogen in the port with electrolyzers from offshore wind parks, but also looking at importing hydrogen from countries which have an excess of hydrogen. Then the next pillar 3, is the new raw materials and fuel system. In that way, we see a lot of developments with biofuels, biochemicals, but also we look at circular economy developments. For example, we recently have been working on a development with looking at circular batteries. So that type of activities are placed in that pillar. And then the 4th pillar, which is actually kind of focusing on for this presentation, is the pillar 4, which is sustainable transport. And therefore, we actually have a separate target as a port authority, which is that we want to reduce 20% of the CO2 emissions within the port and the 60-mile area, which is kind of our control area, for 2030. And that's also including all the terminal extensions, what we are planning to do before 2030. So that's a huge challenge to kind of get a reduction of CO2 with all the new ships coming, which is lower 20% than what we have currently. So that's one of the challenges that I want to discuss about and which I'll focus on my job at this moment. And pillar 4 is actually kind of displayed in this slide. We see there are a number of modalities that we focus on. So it's of course the vessels, the sea vessels, which are the major emitters in our port. We actually say 87% of the deep sea vessels are related to your port. It kind of depends on how much CO2 you allocate to your port. We said that half of the trip from our port or to our port can be allocated to the Port of Rotterdam. Sometimes we also calculate the control area, but it's a huge amount. So what you can do for the deep sea vessels is offshore, you can have projects to reduce their speed, to help like hull cleaning, to ensure that they sail more efficiency. You can also help with digital tools to ensure that their port call will be more optimized, so they can do slow steaming. We work on sustainable fuels. So you see that a lot of activities are outside of the port focus. We are involved in the green corridor with Singapore and Rotterdam, for example, in which we focus on how can we really green this whole transport chain from Rotterdam to Singapore and back with the new fuels, and which is a huge challenge, I must admit. Then within the port, you see, of course, the shore power, which is like a really valuable option to reduce CO2, but also reduce the NOx and sound, actually, we have to admit. So that's like a triple advantage that we have. But like I said, if you have shore power in large scale, you also need to look at your grid. Is your grid sustainable for that? Is your grid allowing that to do that and not taking green electrons from other users, for example, the city itself? So that's a challenge that we work on. And then, of course, we've got the other modalities we've also got the inland vessels, of course, which we also sail, try to let them sail on hydrogen. We test that now. We have 2 barges sailing in our port. We also look at electrifying the barges, so where we put containers on a port, on a ship, which are battery containers, in which a ship can sail, and they swap the containers when they need more energy because the battery is run low. So that's something that we have invested in as the Port of Rotterdam. And then, of course, we've got the other modalities in which we, as a port authority, are a bit less able to steer on that. So, for example, trucks, we can invite them in the port. We have just opened a hydrogen fuel station, which you can also charge your trucks. But, of course, we really depended on other stakeholders in the area outside. So, but that's like the sustainable the activities that we do on reducing all this NOx and SOx emissions in the port. And I think I'm going to dive in. I still got 4 minutes, so I hope I'm fine. I'm going to dive in a specific project, which is in this Pillar 4, so in the sustainable transport, and it's called Magpie. It's funded by the Horizon 2020 call, and it's actually aimed at ensuring that the innovation or some of the innovation that is needed to green your transport is actually happening and demonstrated. We actually are a sister project from a project which is called Pioneers, which is from the Port of Antwerp. But as Magpie, we are combining with 4 other ports in Europe, a Portuguese port, a French port, and a German port, and of course Rotterdam, to work together to see what kind of innovations are needed and can we test it and can we demonstrate it, but also to create a master plan. So within this project, Magpie, we worked together for 5 years with 45 partners. You see them in a really large slide. So we work on innovations, but we also work on a master plan, which I had. I'm going to dive a bit more in the demonstrator itself. So those are innovations, which are kind of almost at a commercial level, but still needs to have research. I'm going to pick a few. For example, ammonia bunkering. That's not the best one in the nitrogen, in the NOx example, but you see that deep sea vessels are kind of looking at methanol or ammonia as a future fuel at this moment. But we have already in the Port of Rotterdam, we've done an ammonia bunkering, so we already have a safety framework for that, so we can ensure that it's being done safe for the people working there, but also for the citizens. But ammonia bunkering is still in development. There's no bunkering, there's no vessel yet at this moment sailing on ammonia. But now we are developing this framework already, because normally it takes with LNG, it took us about 10 years to get everything working. And now we want to speed up. So that's why we're already developing this framework in order to be ready when it's actually being able to be bunkered. And we're actually going to test a ship-to-ship bunker to see if we have done everything that's needed. So then we as the Port of Rotterdam are ready for this ammonia bunkering, but we want to do it in a European level, so to ensure that all the lessons that we learn, we can share it with other ports, so we get standards and we get ready for the new future for all the vessels. I'm also gonna show you another one, which is the offshore charging buoy. The offshore charging buoy is actually an idea in which you want to connect an offshore vessel with a wind park. So they get like it's kind of like a shore power activity in which they be electrified during the stay offshore. At this moment, they're going to test it for maintenance vessels within an offshore wind park. But the idea is at the end that they're going to be able to anchor, to provide electricity directly to anchored ships. So if they are able to do that on large scale, that will be really interesting for ports. For example, within the Port of Rotterdam, we have a huge anchoring area with also the emissions which come, is a combination of that. I'm going to tell you also about the green energy container, which is actually the swappable battery that we have for an inland vessel. We're going to also test it for hydrogen. So the end idea is that if an inland vessel wants to do shorter trips, they can use a battery container and swap it when they need it. But when they need to do longer trips, then they are able to use this battery container, use a hydrogen container with the same connection, and then sail further on. So you can, in that way, if you have this infrastructure on a ship and you have the infrastructure on a port, you're able to supply inland ships either on the needs that they have, and sometimes it's short sailings and sometimes it's large sailings. So in that way, you can just spread the use. And that's the idea in order to kind of convince the inland shipping segment to take this step. So that was, you've seen all the demonstrators in the slides, and please feel free to visit our website to see more about that. Of course, we have also got some tools that's developed. One of them is green energy matching tool. So you see this huge development on what kind of energy do you need and what kind of energy is available. And for example, this testing with shore power is one of the examples that we tested that and we developed that. Sorry. And then last, I'm going to talk a small bit, but I'm always past my minutes, about the master plan itself. The master plan is the combination of every work that we are doing with all the innovations that we are developing, but also go beyond. So the idea is that we are developing a plan for all ports to be used to get more green, to get future-proof and help and find them easily all the innovations that are applicable for them itself. So it goes beyond the innovations that we have in Magpie, but also use the innovations in Pioneers, but also innovations which are out there or trends that we can see. So for them, it's the idea is that ports can quite easily find what kind of toolings are especially applicable to their situation in order to help them to get more green. So I'm responsible for that challenge. I'm responsible for that challenge in the next couple of years. So still about 3 years to dive into this one, and any help for that, any innovations is really welcome. So feel free to contact me in case you've got any questions or any ideas in order to upgrade this master plan. Because as we know from the previous presentations, we've all got a challenge, and I think we really need to work together in order to ensure that all the emissions, either CO2 or the nitrogen one, are being lowered, and I think we really need to help each other. So thank you.